Hi there. Introduction to Probability Part 2. How exciting. First of all, let's just remind ourselves of what we mean by probability up here, or how we calculate the probability. Probability of something is a fraction is the kind of the easiest way to think about this, I think. And it's how many ways of winning on top of the fraction divided by the total number of possible outcomes underneath. Now, of course, you could actually do that division and give yourself a number. For example, it might be, what's the probability of getting an even number on a regular dice? Well, there are 6 possible outcomes on a dice, 1, 2, 3, 4, 5, 6. And the even numbers, there are 3 of those. So you could write it as a fraction of 3 over 6, or simplify that to be 1 out of 2. Or, of course, you could write it as 0.5, 1 divided by 2, right? Okay, and of course, there is another way you can write probabilities, and that was with percentages, so it could be 50%. So fractions, decimals, percentages. But the fraction one, I think, is a great starting place for writing down a probability you've worked out. Now, sometimes we're asked to list all the combinations of different outcomes, though. So not necessarily probabilities as such, but actually working out what all the different combinations could be from a couple of events. So for example, let's say someone takes 2 counters from this bag at random. Okay, there's a load of red, yellow and green counters, and they take 2 at random. Well, what are all the different outcomes? So it might say list all these different outcomes. And so the first thing you might start with is something like this, RR, standing for red, red. Usually, instead of having to write out the words all the time, using initials is usually enough. So red, red could be the first one, or maybe red, yellow, or maybe red, green. So there's 3 options that you could initially have. Now, I'm actually going to, if you notice here, what have I done? I've gone red, 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 yellow, red, green. I've kind of fixed one of my variables. I've fixed that I'm going to say, right, I'm going to pick a red first. What are the other options for the second counter? All right, so you sort of fix one and then do all the other options. When you've run out of options for the second counter, I'm going to go back to the start and change my first one again. This time I'm going to say, well, I'm going to get a yellow first. So what are the 3 things I could get with a yellow? Pick a yellow out, and the second one could be red. Or I pick that yellow out, and the second one could be yellow as well. Or I pick my yellow out, and the second one could be green. So yellow, red, yellow, 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 green. And this is what we expect people to be able to do when we're listing these different outcomes, is do it systematically. So we're the system. Fix one of them, do all the other options for the other one. And then change that first one, but keep it fixed again and do all the other options. And this time I'll choose the next option for the first one, which could be green. I'm going to keep that fixed through all 3 of my other options for the other counter. I'm going to keep the green fixed. Okay, red fixed, then yellow, now green. So what are the 3 options for the second counter? Well, it could be green and then red, green and then yellow, or green and then green. And using this method, I know when I've done enough, possible combinations, right? There's 1, 2, 3, 4, 5, 6, 7, 8, 9 combinations. There's actually, I'm not going to talk about this too much because this may be for another time, but there's actually a way that you can check how many combinations there are. And it's called the product rule. Product meaning times, right? So it's kind of like the timesing rule. Well, there are 3 options for the first counter, red, yellow, or green, okay? So that's the first one. And there are 3 options for the second counter, red, yellow, or green. Hang on, I'm just going to tell Alexa to stop beeping at me. Now, I've got 3 options for the first one, 3 options for the second. Now, this is called the product rule because we're going to do the products, which is another word for times. So it's like the timesing rule. Now, 3 times 3 is 9. There are 9 different combinations, and so I must have all the combinations. So this thing at the bottom, this product rule or timesing rule, is something we'll learn about in the future. But you might want to start sort of thinking about that. How many options for the first task? How many options for the second? And then multiply it together. It just tells you how many options there are. Right, anyway, what I want you to do here, you're going to select 2 counters at random from this bag again. There are 3 options for the first counter, red, blue or green. And there are 3 options for the second counter, red, blue or green. which means, again, there will be 9 different combinations. Okay, so I want to see all 9. It started you off with the first one, which is BB, which stands for blue, blue. So pick a blue one out, pick another blue one out. Write all the other combinations. Pause the video, unpause when you're done. So you've unpaused. Right, let's keep this first one fixed. Let's say the first one's a blue. So let's say that's going to be the blue for this first row. So we could get blue, blue, or blue and then green, or blue and then red. There's my first 3 combinations. Now, it's worth saying, it doesn't matter what order you do these combinations in, as long as you get all of them. Now, we've done all the ones where we get blue for the first one. Let's go with green for the first counter. What are the 3 options for the second one? Well, again, it could be green and then blue. It could be green and then green. Or it could be green and then red. Okay, I'm trying to keep it systematically using my system of my 3 colours. So I've done all the options for the green being first, so let's go for the red being first this time. And it could be red with blue. It could be green. No, it's not green. What am I talking about? No, here's me saying keep it fixed, and then I'm starting doing random ones. That's no good. That was a good example of what not to do. So red with blue, red with green, or red with red. There are my 9 options. As long as you've got all 9, it's all good. But try and use a system. Right, a restaurant has a choice of 3 starters. So when you go to the restaurant, your little starter, the little kind of appetizer you get, someone could choose soup, or prawns, or melon. They can only have one. There's also a choice of 3 main meals. It's a very basic restaurant, this. Fish, steak, or lasagna. Let's presume it's a veggie lasagna. Right. So, 3 choices for the starters, 3 choices for the main. Right, list all the different possible outcomes of what people could choose. Keeping in mind what they could choose for the starter, what they could choose for the main. There are going to be 9 again, because there's 3 options for the starter, 3 options for the main, and using our product rule, that means there must be 9 combinations. I've started you off with soup and fish. You can just use the letters if you want. S, P, M, F, S, and L. Okay, up to you. Pause the video, write them all down, and then unpause when you're done. Okay, so you've done soup and then fish. I'm going to keep the soup fixed here. It could be soup with fish or soup with steak. Or, excuse the writing here, I'm going quickly, soup with lasagna. Good old lasagne. Alright, so soup with fish, soup with steak, soup with lasagna. There's 3 options. But they might have had a different starter. They might have had the prawns. In which case, they've got prawns, but again, they could have had prawns with frish. I'm not sure what frish is. I don't think they sell frish in this particular restaurant. So I think this time we'll stick with fish. And then we'll go prawns with steak. And then we'll go prawns with lasagna. Okay. So we've done all the prawn options. Let's go for the melon. It could be melon. Again, it could be melon with fish. It could be melon with steak. Or it could be melon with lasagna. Yeah. Okay, 9 options. Or 9 different combinations of them. Okay, cool. Nice one. Right, so that is something that can come up. It's pretty straightforward, but the main thing is try and keep it as a system. Make sure you're sticking to some kind of system that you've got to make sure you're not missing any out. Right, okay, here's the main thing for today, I think. Sample space diagrams. Let's say that I'm rolling 2 dice. Or as people would say. No, it's dice, it's plural, isn't it? 2 dice, and I'm going to roll those dice, and I'm going to add the numbers together to get a score. So if I'd rolled these 2, I would add the 2 6s together to get a score of 12. That's my sort of result. Okay. In that case, what's the probability if you do that? What's the probability of getting a 5? What's the probability of more than 8? Or what's the probability of less than 4? And what's the most likely score? Now, there are going to be a lot of combinations here, because let's do our product rule again, actually. There are 6 options for the first dice, 1, 2, 3, 4, 5, and 6. And there are 6 options for the second dice, so 1, 2, 3, 4, 5, 6. That means in total, there are 6 times 6, 36 different outcomes. Now that's going to take a long time to list, right? So what we're going to do here is actually use a kind of chart, a little table, to put all the different results in. And this is called a sample space diagram because it sort of shows me all the different samples I could get, all the different answers. Draw a sample space diagram is what we're talking about. Now this comes down to when you've got 2 events. What are my 2 events here? Well, the first event is rolling dice number 1, and the second event is rolling dice number 2. 2 events. Sample space diagrams are for 2 events. Okay? Not just 1, but 2. And let's start off like this. So we draw a couple of lines, and we put across the top, the results of 1 dice. Let's call that dice 1. And we put down the side the results of the other dice. Let's see if I can write sideways. Dice 2. Okay, so all the different outcomes that I could get on dice 1 and dice 2, which is 1, 2, 3, 4, 5, or 6 on the first dice. Oh, 1, 2, 3, 4, 5, and 6 on the second dice. Okay, and then we can start filling out the middle of our sample space diagram. Now, what is this one? This says add, isn't it? It said when you add the numbers together, you get a score. So you roll the dice. Let's say I rolled it. I'm not sure where that came from. Rolled a 1 on my first dice and a 1 on my second dice. That outcome would give me a score of 2. So there is 1 of my 36 outcomes. But what if I rolled a 2 on one dice and a 1 on the other dice? That would have a score of 3. If I rolled a 3 and a 1, that would have a score of 4. Just because this is what our thing is set up as, which is that we add the numbers to get the score. And then 1 and a 4 would be a score of 5. If I rolled a 5 and a 1, that would be a score of 6. And a 6 and a 1 would be a score of 7. Okay, get the idea? So I want you to draw this out, copy this question down as an example. Draw out the sample space diagram, use a ruler for the lines please, keep it nice and clear, and fill it out for all 36 different outcomes. So you need to pause the video now. When you've done all that nice and neatly, unpause please. Cool, okay, well hopefully you've done that. It does take a little while, but when you get into it, it goes quite quickly. Now, I'm going to get rid of those because it would be much neater if I just write in computer language. So 2, 3, 4, 5, 6, 3, 4, 5, 6, 7, 8. You've probably noticed a pattern here. 4, 5, 6, 7, 8, 9. 4 up to 5 up to 10, 6 up to 11, and 7 up to 12. Right, all those ones in black there are 36 different outcomes that I could get. And I can use this to work out my probabilities. Now remember, probability is the number of ways of winning divided by the total number of outcomes. Now the total number of outcomes is 36. There's all 36 of them. So my fraction will be out of 36. Now what is my first question? Oh yeah, P of 5. Probability of rolling a 5. There's not just one way of getting a 5. There's actually 1, 2, should I just circle these for now? 1, 2, 3, 4 different ways of rolling a 5. So my answer is 4 out of 36. You could simplify that to 1 out of 9. Or maybe 0.4 recurring, which is... or no, it's 1/9. Sorry, 0.1 recurring. But it's neater as a fraction, and you don't really need to simplify it unless it asks you to. So 4 out of 36 is fine. Let's change colour. That's probably the easiest way of doing this. Let's go for red. What about more than an 8? How many of these are more than 8? Now, I can't include 8, because 8 is not more than 8. It is 8. Right, so 9 would be the first ones I could get. There are 4 of those. And then 3 10s. 11s, all of these results are more than 8. And there are 4, 5, 6, 7, 8, 9, 10. So my second question would be 10 ways of winning out of 36 different possible outcomes. Again, you could simplify it to 5 out of 18. Anything that's equivalent is okay, but generally I only simplify if I really need to. And then less than 4. Well, less than 4 would be a 3s or a 2. 2's the lowest score I can get. So there are 3 different options for winning of less than 4 out of 36 again, or maybe 1 out of 12. Right. Now, what's the most likely score? Right, we need to see the result that comes up the most. And there are 5 6s, there are 5 8s. But this one in the centre here is the one that actually seems to come up the most. 7 is the most common number when you roll 2 dice together and add the score. So 7 is the most likely score. This is a sample space diagram. Pretty straightforward, isn't it? But you just need to keep it neat. Keep everything in rows and columns. Cool. Well, now you know what you're doing. I would like you to do this. I want you to do a sample space diagram for rolling 2 dice again. So just like this, just roll 2 dice and multiplying to get a score. So this score up here, instead of being an answer of 12, if I rolled a 6 and a 6, I would do 6 times 6. So my score would be 36. Right? So it's just like this one, except we're multiplying, and then you can fill out all the numbers in your sample space diagram. Pause the video, please. Unpause when you have neatly done that and written the question out, okay? Oh, and answered these bits of probabilities as well. Off you go. Okay, now I know it's gone to a new screen, but this is actually still the same question. So sample space diagram for rolling 2 dice and multiplying to get the answer. So we'll draw a sample space diagram, and this time we're going to multiply to get our answers. Let's do, so dice 1 we'll do on one side, and dice 2 along the other. And of course it's the same outcome initially, or outcomes for the different individual dice, 1, 2, 3, 4, 5 and 6 for both of them. But this time we're going to multiply to get our answers. So 1 times 1 would be 1. So actually 1 is the lowest score this time. 1 times 2 is 2. 1 times 3 is 3. It's a bit boring going along this one actually. Let's go for the next row. Now 2 times 1 is 2, but 2 times 2 would be 4. And all of these are different outcomes. 2 times 3 is 6. 2 times 4 is 8. You know, I'm right in the bottom corner. 6 times 6 would be 36. All right? But as before, because I know my writing isn't fantastic, it's not really neat, even though I do try my best. I promise. I've actually written out and typed them up the different numbers you should be going. So you might want to just quickly pause and just check you've got all those correct before we move on. But presuming you have got them correct, let's look at what we do for the probabilities. Now, if you haven't done these probability questions yet, I want you to pause, do them, and then unpause again. But otherwise, we'll carry on. P. What's the probability of more than 24? Okay, what's more than 24? Well, that would be 25, 30, 30, and 36. Actually, it's 4 out of the total number of outcomes. Now, again, there's 36 different outcomes. You could know that just from counting up all these numbers. There are 36. What about less than 10? Let's have a look. What numbers are less than 10? 6s, 5, 4, 3, 2, 1, blast off. 8, 6, 9 is less than 10. 8 is 5, 6, the 2, the 3, the 4, the 4 and the 6. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 17 ways of getting less than 10. Again, out of the total number, which is 36. What about a square number? Right, square numbers are, like 1 times 1 is 1, so that's a square number. 2 times 2 is 4, that's a square number. 3 times 3 is 9, that's a square number. 4 times 4 is 16, 5 5s are 25, and 6 6s are 36. Now, there are, of course, more than that. There's an infinite amount. But 1 is a square number, 4 is a square number. In fact, you'll notice it's on this diagonal, isn't it, where you've got, say, 4 times 4, or 5 times 5, or 6 times 6. And there are 6 of those out of a total number of 36. What about the probability of an odd number? Now, there's going to be loads of these, so let's get a completely different colour and start crossing things off, I think. Let's have a look. An odd number. Right. 1, 2, 3. None of that row. 4, 5, 6. None of that row. 7, 8, 9. And none of that row. There are 9 odd numbers out of 36. So it's actually more likely that you'll get an even number. And that comes from when you multiply evens together, you get an even. An odd and an even still makes an even. You only get an odd number when you multiply 2 odd numbers together. Don't believe me? Have a look. Cool, I hope you got those right. So sample space diagrams, I don't think they're very complicated, but you know, they do take neatness. We need to be good mathematicians here, making our work nice and neat. Okay, so a couple of questions for us to do then. I'd like you to just quickly draw out the sample space diagrams. So these are generally quite small, not as big as the last two. And then answer any probability questions. The bag 1, the counters are labelled 1, 2 and 3. In bag 2, they're 1, 2 and 4. A counter is drawn at random from bag 1 and a counter is drawn at random from bag 2. So we take 1 from each and the two numbers are added together to get a score. Do a sample space diagram, answer these two questions. So one side of the diagram will be for the counters from bag 1, one side will be for the counters from bag 2. I'm guessing you're done and you've unpaused. So they've started one off for us. Remember, we're adding to get our score. So that was a 2. Let's just go over these in red so they stand out. 1 and 3 makes 4. 2 and 1 would make 3. 2 and 2 makes 4. 2 and 3 makes 5. 4 and 1 also makes 5. 4 and 2 makes 6. And 4 and 3 makes 7. So there are the 9 different combinations we could get, or 9 different outcomes we could get. Probability of a 4 then. Well, there are 2 4s, 2 ways of getting 4, out of a total of 9. So 4 ninths, or less than 5. That would be that top row. So that's 1, 2, 3, 4, 5 different ways of getting less than 5, and it has to be less than 5, not including 5, out of 9. So 5 ninths. All right? Okay, if you didn't get that, try again. Maybe watch that bit again. Otherwise, let's move on to another question. This time we've got a spinner with 4 numbers on and a coin. We're going to spin the spinner, flip the coin. Now, here's the thing. If the coin lands on heads, his score is 1 more than the number on the spinner. You're going to add 1 to the spinner score, right? So we're still getting a number as our answer. If the coin lands on tails, the score in his spinner is doubled. So if it's heads, you just add 1 to it. If it's tails, you double the score. Okay? Remember, 2 events, 1 for the spinner, 1 for heads or tails. And then unpause when you've done that and you've done the probability questions. Okay, so we've got heads and tails, and we've got the spinner score. Now remember, when we get heads, we get 1 more than the score. So that would be a score of 2. That would be a score of 3. That would be a score of 4. And this would be a score of 5. Now when we get tails, we double the score. So 1 would become 2. 2 would become 4. 3 would become 6. And 4 would become 8. What's the probability that we get a score of 5? Well, there's only 1 of those out of 8 different outcomes. In fact, let's do our little product rule for counting, our timesing rule. There are 4 outcomes on our spinner, and there are 2 outcomes on the coin. Multiply those 2 together, 8 different outcomes. There they are. See, it works. Right, anyway, probability of 4 or more. So how many scores are 4 or more? Well, the 4s, because this time it says 4 or more, so we can include 4. 1, 2, 3, 4. There are 5 different ways of getting 4 or more out of 8, so 5 eighths. And what's the probability of getting an odd score? Well, that's the 3 or the 5. That's only 2 eighths, or maybe you wrote a quarter, or 0.25. Cool. Good stuff. Right, off to Dr. Frost with you. And there aren't many questions on here because it takes a while to draw these sample space diagrams, but I do want you to draw them where it asks you to. And then answer the probability questions as well, please. All right, please take your time, make sure that it's nice and neat, and then I'd like to see, obviously, a photo of your work. Otherwise, good luck, and I'll see you next time. Bye-bye.